Hello guys, in this video I'm gonna go over a shortcut you can use to know whether the substituents in an electrocyclic reaction will form a trans or a cis product. In order to use the table I'm about to show you, you have to first find if the electrocyclic reaction is this rotatory or con-rotatory. Once you have find out that, you can use the following table. If you move in a this rotatory manner in a EE or ZC molecule, when it is open, when it closes, it will give you a cis product. If it moves this rotatory, it is EC or ZE, it will give you a trans. If on the other hand, it moves con-rotatory in an EE or CC molecule, when it closes, it will give you a trans. Finally, if you have a con-rotatory movement in an EC or CE molecule, when it closes, it will give you a cis. The first example that we're going to go over says, what product is formed when 2E4C6C and a 2,4,6 tri-ene undergoes a thermal electrocyclic reaction? Before to use the table I showed you before, and that we have here in the bottom, we had to find the symmetry. We know that it has an odd number of pi bonds, and because it is being heated, it is a thermal reaction, its HOMO stays in the ground state. Because its HOMO is in the ground state and it is odd, it is symmetric, and it will move in this rotatory manner. We look at our molecule, and first we can do for this one that we have symmetric lateral p orbitals, and we move this rotatory. But to find the configuration of the closed molecule, we could look at our table, and we said it is this rotatory. It is, here we have an E and a C, E and a C, and according to the table, we're gonna get a, of course we have to do this, we're gonna get a trans product, of course with the enantiomer. Also, to clarify something guys, in this table, when we talk about EECC or EC, we're talking about the ones that are in the corners, lateral. We are not taking into account this one. This one is always Z. We are taking into account these two because they're the ones are gonna close the molecule and will affect the stereochemistry. Now, if the molecule undergoes a photochemical reaction, we apply light, its HOMO will go to the excited state. Because the HOMO in this molecule, in the excited state that went one up, is unsymmetrical, the movement will be con-rotatory. We look at our molecule, we'll see that we have an E and a C. And remember, for this table, we are not taking into account this one because it is a constant. We're just taking into account these two, the lateral ones. If we look at our table, you can see that we have current rotatory movement and then EC or CE, and it should give us a cis configuration. Plus and enter. This question says, what product would form when 2E4E hexab 2,4-ene undergoes thermal electrocyclic reaction? We can see that this one has an even number of pi bonds, and it is in the ground state because we are using heat. Because it is even, it is in the ground state, we know that the molecule is unsymmetrical. When we look at our molecule, in this case we just have the ones that are lateral, so we have the EE configuration, and we look at our table. We know that it's going to be, because here's unsymmetrical, it is going to be current rotatory movement, and we look at our table and we have current rotatory of an EE, and it should give us a trans. Plus it's an enantiomer. We can also show this. And we have our answer. If on the other hand, we apply light and it undergoes a photochemical reaction, we can see that the HOMO will go to the excited state. And in this excited state, because it is odd, we can see that it's symmetrical. Because it is symmetrical, it will go in this rotatory manner. And as before, we can see our molecule, and we have E. We set this rotatory. We have, in this case, EE. We should get a cis. And just to review, because it has a plane of symmetry, it doesn't have an enantiomer. It is equal from either side. To finish this video, we are going to do an exercise in which we are going to work backwards in contrast with the other ones. And for this one, we have to start looking for the number of pi bonds. But we don't have the open structure, so we have to first open the ring and we get this. Now we're gonna try to see how these C's will move in relationship to this one when it opens. So we can get our EE or CC or EC. First, we see that it is in a thermal reaction, and we know that it is in the ground state because of that. We know that we have an odd number of pi bonds, and because it is in the ground state, it is symmetrical. Because it is symmetrical, it will move in this rotatory manner. Now, we really do not have anywhere to see if we have an EE, a CC, or EC in the variables that we are given. But what we can do is to look here. We know that we have a cis, and we know that the movement is this rotatory. So we look at our table and we said we have this rotatory, and here we have a cis. So the only one that gives us this one would be an EE or CC. And in this case, we have this and this. We have an E and another E. Well guys, I hope this video has been helpful to you and that this table works well when you do the exercises, and I wish you luck guys.